In December 1969, snow began falling along Colorado's Front Range in a rhythm that would soon feel less like weather and more like occupation. The storms arrived without particular drama, modest systems dropping 3 inches, then 5, then 7. But they arrived often, and between them the sky stayed gray and close. Denver, Boulder, Fort Collins, cities pressed against the foothills where the Rockies met the Great Plains, accustomed to heavy snow followed by bright sun and rapid thaw. That winter, the sun did not return with any consistency. The Front Range corridor had always existed in a particular meteorological tension. Cold air pooled along the eastern slope of the mountains, and upslope winds carried moisture from the plains into that cold reservoir, wringing out snow with mechanical efficiency. Normally, high-pressure systems would sweep through every few days, clearing the air and warming the ground. In late 1969, those clearing patterns faltered. Storm systems moved through in close succession, separated by brief intervals of cloudy cold. Temperatures hovered in the teens and 20s Fahrenheit. The snow that fell did not melt, it waited. By mid-December, residents noticed the persistence more than the intensity. Snowbanks along residential streets that would normally shrink between storms instead grew taller. Rooftops stayed white week after week. The light took on a muted, diffuse quality, filtered through cloud cover that rarely broke. Life continued, people went to work, schools stayed open, freight moved through the rail yards, but everything proceeded more slowly with more effort against a backdrop that refused to reset. There was no single storm to mark as the beginning of the problem, only the gradual realization that winter had arrived and was not behaving according to pattern. January came without relief. More snow fell. The intervals between storms shortened. The Front Range cities, built for intermittent winter severity, began operating under conditions for which they had not been designed. Continuous snow cover, continuous cold, continuous accumulation without the periodic pause that would allow systems to recover. No one yet used the word siege, but the shape of it was forming, quiet, persistent, mechanical. Snow does not simply pile higher, it compacts. As each new storm deposits lighter, fluffier snow atop what has already fallen, the lower layers compress under the weight. Air pockets collapse, ice crystals bond and reorganize. Density increases. A foot of fresh snow might weigh 5 pounds per square foot. After days of compaction and partial melting and refreezing in the thermal cycling of shallow layers, that same foot can weigh 15 or 20 pounds. Water equivalent, the depth of water that would result if the snowpack melted instantly, becomes the more meaningful measure of load than visible depth. Along the Front Range through December and January, this process occurred without interruption. Each storm added not just depth but mass. A roof that had supported 12 inches of snow in early December now supported 12 inches plus another 8 from mid-December plus another 6 from late December, all of it denser than when it first landed. The architectural standards of the time accounted for peak snowfall events, the single large storm that drops 2 feet overnight, but those standards assumed melt between events. They assumed the slate would be wiped clean periodically. It was not. Flat and low-slope roofs bore the greatest risk. Commercial warehouses, retail buildings, older schools, and industrial structures often featured broad, unsupported spans designed for economy of construction. These roofs carried minimum structural margins. Engineers calculated loads based on historical weather patterns that included winter thaws. A roof rated for 30 pounds per square foot of snow might handle a major storm and the days immediately following, but it was not intended to hold that load for weeks, nor to have additional load added before the first had a chance to diminish. The snow cover thickened gradually without alarm. 2 feet became 3 feet became 4 feet. Beneath the surface, invisible to casual observation, the transformation continued. The bottom layers turned to dense, consolidated snow verging on ice. The weight per square foot climbed past design thresholds, and still the storms kept coming, feeding more mass onto roofs that had no mechanism to shed it. There was no wind to scour the snow away, no sun to melt it, no rain to compact and drain it. Only accumulation, only addition, only load. Plowing snow creates margins. The blade pushes accumulation to the roadside building berms that define the cleared path. When the snow melts or when weeks pass between storms, those berms shrink and the road returns to its full width. But when snow continues to fall and temperatures stay below freezing, the berms do not shrink. They grow. Each plowing event lifts new snow onto older, compacted snow. The margins narrow. By mid-January, arterial streets through Denver and the surrounding Front Range cities had become corridors. Snowbanks rose 4 and 5 feet along curbs. Intersections lost their corner visibility. Two-lane roads effectively became 1.5 lanes, requiring slower speeds and cautious passing. Residential streets fared worse. Plows prioritized main routes, leaving neighborhood roads with packed snow surfaces that grew thicker each week. Parking became problematic. Fire hydrants disappeared beneath drifted snow. Sidewalks, where they had been cleared at all, turned into narrow trenches. The sensory experience of driving changed. Visibility shrank. Turning a corner meant edging forward into blind space until sightlines opened past the snowbanks. Highway speeds dropped. Drivers learned to navigate by the geometry of the corridor rather than by lane markings buried under packed snow and ice. The Front Range's normally wide, open streetscapes, designed with Western spaciousness, constricted into passages that felt borrowed from older, denser cities. Rail operations suffered differently but no less significantly. Snow filled the spaces between tracks in the rail yards. Switches froze or became packed with ice and compressed snow. Workers spent hours each day clearing points and crossings just to maintain basic operations. Freight cars sat longer in yards waiting for cleared tracks. Delays compounded. The railroads, critical for moving coal from mountain mines and agricultural products from the plains, operated at reduced efficiency precisely when winter demand for heating fuel ran highest. The geometry of movement, road width, sight distance, operational clearance, tightened week by week without dramatic failure, only continuous reduction in capacity. The transportation network did not collapse. It narrowed, slowed, and labored under margins that grew thinner with each passing storm. The collapses, when they began, did not announce themselves. A warehouse roof in Denver's industrial district gave way on a Thursday afternoon in late January. There had been no storm that day, no particular event to trigger the failure. The load had simply exceeded the capacity of the structure. Steel trusses buckled. Roof decking dropped into the interior space. The sound carried across the surrounding blocks, a low, percussive groan followed by the crash of material meeting floor. Inside, stored goods were buried under roofing material, insulation, and several feet of compacted snow. A similar failure occurred at a retail building in Boulder 2 days later, then another warehouse near Fort Collins, then a school gymnasium that had been closed for the weekend. The pattern was consistent: flat or low-slope roofs on wide-span structures, load accumulation over weeks, failure occurring not during storms but in the quiet hours between them. The snow had been there long enough to settle, to bond, to become a nearly solid mass. The structures had held that mass as long as their margins allowed. Then the margins closed. Structural engineers began receiving calls to assess buildings. Walking a snow-covered roof to measure depth and density became a task weighed against the risk of triggering collapse. Some assessments were conducted from the interior, looking for signs of distress. Sagging ceilings, cracked walls, doors that no longer closed properly because the frame had shifted. When distress was found, the building was evacuated and either cleared of snow immediately or abandoned until conditions improved. The failures were mechanical inevitabilities, not catastrophes. Most occurred in unoccupied buildings or during off hours. Injuries were few, but each collapse carried economic consequence: damaged inventory, lost business days, repair costs, and each one reinforced the realization that the snowpack was no longer behaving as a temporary condition. It had become a sustained load, testing the limits of infrastructure that had been built with the assumption of intermittent stress, not prolonged siege. The sound of a roof giving way, audible from blocks away in the cold, still air, became part of the winter's sensory vocabulary along the Front Range, a reminder that even in the absence of active storms, the snow was still working. Commerce adjusted, then strained, then began to fail at the margins. Warehouses that had lost roofs could not operate. Buildings deemed at risk were emptied and closed. Freight that would normally move through regional distribution centers sat in rail yards or on trucks that could not navigate narrowed streets to reach loading docks. Retail stores saw foot traffic drop as customers avoided driving on constricted roads. Delivery schedules slipped. Supply chains, which in 1970 lacked the redundancy and just-in-time precision of later decades, but still relied on predictable transportation, began experiencing delays that compounded across the region. Neighborhoods became harder to reach. Mail delivery slowed. Garbage collection fell behind schedule. Side streets in older residential areas, where homes sat close together and streets had been platted narrow, became nearly impassable. Residents parked blocks away from their homes and walked through packed snow paths. The elderly and disabled faced isolation. Essential services, police, fire, medical, continued but with longer response times and greater difficulty navigating to addresses. The economic geography of the Front Range compressed. Businesses located on well-plowed arterials continued operating. Those on secondary roads or in older industrial districts struggled or closed temporarily. Employment patterns shifted as workers found commutes that had taken 20 minutes in November now required an hour or proved impossible. The region's economy did not stop, but it slowed and redistributed itself according to which locations remained accessible. Snow removal reached a saturation point. Municipalities had cleared streets after each storm, but the volume of snow exceeded the capacity to haul it away. Plowed snow was pushed farther from the roadway into parking lots, onto vacant land, anywhere it could be temporarily stored. But those spaces filled. Crews began hauling snow to dump sites on the outskirts of cities, a logistically intensive and expensive operation rarely needed in the Front Range's typical winters. The cost of snow removal, already high, climbed into budgets that had not anticipated sustained operations. The Front Range cities, which had functioned through December and January with determination and adaptation, found themselves in February operating under conditions that could no longer be managed through routine effort. The snow was not a crisis in the acute sense. No single day brought disaster, but it had become a chronic condition, weighing on infrastructure, logistics, and the basic geometry of urban life. Removing compacted snow is not the same task as plowing fresh snowfall. The snowpack that covered the Front Range by midwinter had consolidated into a dense, bonded mass. In some places, especially where vehicle traffic had compressed it, or where freeze-thaw cycles in shallow surface layers had created ice lenses, the snow had become nearly as hard as pavement. Standard plowing equipment scraped across it without cutting through. Removal required different tools: loaders with reinforced buckets, graders with carbide blades, in some cases jackhammers to break apart ice layers before machinery could lift the pieces. The process was slow. A crew that could clear a mile of residential street of fresh snow in an hour might spend a day working through the same distance of compacted pack. The material, once broken free, had to be loaded into trucks and hauled to disposal sites. Those sites, on the edges of towns or in empty fields, grew into mountains of plowed snow that would not melt for months. The machinery itself suffered. Hydraulic lines froze, blades wore down faster than normal, engines strained under continuous operation in sub-zero temperatures. Labor became a limiting factor. Equipment operators worked extended shifts. Maintenance crews struggled to keep the fleet operational. Municipalities hired additional contractors, but the demand for snow removal equipment and experienced operators exceeded regional supply. Some crews were brought in from outside Colorado, unfamiliar with local street layouts and working under conditions that tested both equipment and endurance. Meanwhile, the weather offered no sustained assistance. Brief periods of above-freezing temperatures in late February brought hope of natural melt, but they were too short and too weak to make significant impact on a snowpack several feet deep. Surface layers might soften during the day, only to refreeze at night into harder, slicker ice. The partial thaws sometimes worsened conditions, creating layers of ice within the snowpack that made mechanical removal even more difficult. The cost mounted. Denver's snow removal budget, exhausted by January, required emergency appropriations. Smaller municipalities faced similar shortfalls. The expense was not just financial but operational. The sheer expenditure of time, fuel, and human effort required to fight snowpack that resisted every attempt to move it. By late February, the Front Range had been clearing snow continuously for 3 months, and much of it still remained. In early March, the weather pattern finally shifted. A series of warmer systems moved through the Front Range, bringing sustained temperatures in the 40s and 50s Fahrenheit and occasional rain. The snowpack, which had resisted weeks of mechanical effort, began to yield to thermal energy. Melt accelerated. Runoff filled storm drains and ditches. The urban landscape, which had been white and constricted since December, opened back into its normal geometry. Streets widened. Rooftops cleared. Visibility returned. The accounting came gradually. Documented roof collapses in the Denver metro area and surrounding Front Range communities numbered in the dozens, with hundreds more structures showing damage short of total failure. Economic losses from building damage, business interruption, and snow removal costs reached tens of millions of dollars, a significant impact in 1970 terms, particularly for a winter weather event that involved no single catastrophic storm. Transportation delays and supply chain disruptions had rippled through the regional economy for months. The costs were distributed, cumulative, difficult to tabulate precisely, but undeniably substantial. Engineering and planning communities took note. The winter of 1969-1970 had demonstrated that duration and accumulation could exceed the damage potential of intensity alone. Existing building codes, which specified snow loads based on historical peak events, did not adequately account for sustained loading over extended periods. In the years following, Colorado revised its structural standards. Snow load requirements for flat and low-slope roofs increased. Design standards began incorporating assumptions of longer snow retention and less frequent melt cycles. The 1970 Uniform Building Code revisions reflected lessons from the Front Range winter, emphasizing not just peak load capacity, but sustained load endurance. Municipal snow removal planning changed as well. Budgets increased. Equipment reserves expanded. Protocols for compacted snow removal, previously considered an edge case, became standard procedure. The assumption that snow would melt between storms, a reasonable expectation based on Front Range climate history, was replaced with contingency planning for winters when it would not. The snow left quietly without ceremony. It drained into rivers already swollen with mountain snowmelt, flooded a few low-lying areas, and then was gone. The Front Range returned to its spring rhythms, but the assumptions that had governed how the region built and planned for winter had been altered. Snow was no longer understood merely as precipitation. It was recognized as a load, a duration, a risk, one that could accumulate slowly and weigh heavily long after the storms had passed.